Good afternoon, everyone. My name is Keith Murray. I'm here today to give a brief introduction to UniTime. It's a comprehensive timetabling system that we've developed. We're new to Apereo. We've been around a while, but mostly our work has been with the research community. We started as a project to develop a timetabling and scheduling system for Purdue University. We've recently, a month or two ago, entered the Apereo incubation project process. So I'm here today just to meet some of you all. We hope to forge some connections with people who are interested. And that'll launch into an explanation of what we've been up to. I think for many of you, the first question may be, what is educational timetabling? Very simply, it's the process of assigning classes to times and locations. Maybe not so simply. It ends up being a difficult optimization problem with many competing objectives. There's student conflicts that get involved, faculty requirements, space constraints, and lots of politics along the way. Why is it needed? As we approach the problem, we feel that we want to minimize the number of student conflicts occur. We're here to provide students with an education and to help them to receive their degrees on time. That's really what differentiates us from a lot of other processes for scheduling at universities. We also want to help make the best use of limited resources that we can, make the process more understandable and sustainable. There's no single point of failure. The one person in the closet somewhere at your university who knows how that timetable was put together, if anything happens to them, they're a vital loss to your institution. We also want to see that there's more fairness in the timetable. If people don't know how it's constructed, there's always suspicion as to someone out to get them. It's usually not the case, it's just a very difficult problem, and people are trying to do the best they can with it. It's also the ability to adapt to change. I know my institution isn't static. A lot of changes occur, which means we have to make changes to the timetable, whether it's curricular changes in facilities, that we have to adapt to. And we wanted to have a system that was much more flexible than what we could do previously. Having said that, there currently is a gap between what we do in practice, which is mostly rolling forward the last timetable, reusing what we've done as long as possible. I've heard of instances where institutions have basically had the same timetable for 40 years, and if something new changes, they have a lot of trouble. Research, on the other hand, has made a lot of progress in solving or coming up with potential solutions to timetablings over the last couple of decades. There have been a number of useful algorithms which have been developed, and computer capacity has expanded greatly and has the ability to solve some large-scale problems as opposed to just departmental problems, which has been typical in the literature. So how does UniTime help fill bridging this gap? As I said, we began as a research project. It's been actually 14 years ago now, in the year 2000. Our goal was in producing, at that time, the large lecture timetable for Purdue University, where I work. In order to do so, we made use of the existing timetabling research and actually expanded on what had been done quite considerably in order to address the problems of a large institution, to the point where we now really do provide a viable and very useful solution that can be used to meet a wide range of university timetabling needs. We position ourselves as a comprehensive academic scheduling solution. What does that mean? We do both course timetabling, that's the creation of the schedule of classes, exam timetabling, individual student schedules, the creation of those schedules for each student who comes through, and we do event scheduling into the rooms that we do timetabling for. system is based on state-of-the-art algorithms that have been developed in the research community by us and by others that we borrowed from. It's an open source system, web-based, based on Java and other technologies. And it allows for both distributed data entry and solution of the problem in multi-user environments. So it can be distributed across campus, across multiple campuses, pretty much whatever scale is required. I'd like to explain a little bit about the major components. The first, where we started, was course timetabling. In course timetabling, you have quite a few constraints on the problem. From the rooms you can use, what are their sizes, what equipment, what the availability of those rooms are. We have faculty who have time preferences, or in some cases requirements on when they cannot teach, what room they want. I want what's next to my office, or I want this special room that has just the equipment I want to teach my course. What the structures are of the courses that are offered. Is it a simple lecture, or is it a more complicated structure to your course where you have a lecture, laboratories, and discussion sections, and how do those need to relate to each other? And then, very importantly, we have student demands. What are the courses that your students want to take? If you try and build a timetable without regard to what the needs of your students are, I'm in a program that I need a degree in nursing. If I don't look at what the requirements are for those individual students and what courses they need, I'm not going to build an effective timetable that's going to allow them to make progress toward their degree. Our goal in all of this is to design the classes to times and locations in a way that is going to meet those demands, minimizing the student conflicts, making sure we accommodate the room requirements and preferences, allow for class time distributions throughout the week and throughout the student's individual schedule, and we want there to be some fairness in the results of the problem. When I go into a little bit more into student conflicts, the obvious student conflicts are when classes overlap in time. So in this case, you can see where biology and chemistry overlap on our time period horizon, which is across the bottom. Very difficult, impossible for a student to take both biology and lecture and chemistry lecture. There are other types of conflicts, however, which may not involve as apparent an overlap. For example, if the student's wanting to take a math class, that's possible to do because there are multiple sections of that math class until the class that if they take lecture A is filled and the only thing is available is lecture B, and I also want to take the stat class. There's space in the course, but there's not space that's available to me. So there are a number of different types of conflicts that can occur. The other thing we have to watch out for is that course structure, so that the chemistry class has a lecture and 2 possible laboratories. We have to make sure that we can't have a conflict. You wouldn't be able to take the math lecture A at the same time you're taking chemistry unless you get into lab B of the chemistry class. So there are a lot of things that get built into the problem that we have to look at in terms of conflicts. In order to help deal with that, UniTime presents classes with all of their course structure. We try and provide an intuitive entry and display that you can understand what your classes are. So in this example, we have a class, Math 170. It consists of lectures and laboratories. By the way, you can also get into this class by signing up for Stat 170. Most institutions have cross-list or joint-listed classes. They go under a number of different names. At UniTime, we treat that as a pseudonym for the class. It's really one class, so you can call me Math or you can call me Stat. In the end, you're in the same classroom with an instructor. So that makes it much easier to schedule classes. You're not doing all kinds of joint linkages between them. you're dealing with a class entity, and that class entity has a structure that consists of a lecture and lab in this case. Specifically, there's one lecture and 2 laboratories in this class, so that you can see all of that as you're looking at the data entry and as you're looking at the listing of classes in the interface. UniTime uses a constraint-based solver. We model timetabling problems as a constraint satisfaction and optimization problem. That's why the constraints that I mentioned are important to us. We work with the constraints on the problem as well as the possible time placements and room placements of a problem. Those placements are limited by the constraints that you impose. We use a number of state-of-the-art methods in order to achieve this. I won't go into all of the details. We have plenty of information on our website. The work we've done has been published in a number of refereed journals, however. And I'm very pleased to say that we're the winner of a recent international timetabling competition that had 3 tracks. We were the winner of 2 of them and the runner-up in the 3rd, all components of which are used in the timetabling software we have. So we're giving you state-of-the-art ability to solve your problems. Being a constraint-based problem model, it's also easy to extend. If you have additional constraints that apply to your institution, it's possible to add constraints into the model in order to solve a particular instance of a problem that may not be in the software as we have it written at this time. The application allows for distributed timetabling with sharing of resources. At Purdue University, a very important element in the problem for us was the fact that we have about 70 different units, academic units, departments, trying to work together on the timetable. And we didn't want to take the responsibility away from those units. Someone in the math department best knows what the needs of the math faculty are in terms of solving the problem. They also know what are in best touch with what their course needs are and what the curriculum demands are. If we tried to centralize that, there would be less satisfaction with the solution. It becomes, here's someone in the registrar's office imposing this solution on us rather than we have some control over it. So we opted for creating a multi-user environment that allowed them to both enter the data and solve their problems. And we also allow, and a more typical use for many of the institutions that have adopted UniTime, is for distributed data entry with a centralized timetabling entity such as a registrar's office providing a solution. So we can be used in a number of different manners in order to come up with a solution. We also try and manage the class scheduling process over its entire lifetime. Obviously, we have the ability in our interface to do data entry, but we also have a number of ways that we work with the problem on the timetabling. Typically, we'll run through an automated solution. We'll take all of the data into the problem, try and optimize and get the best solution possible. But the best solution possible is only for that problem you enter. Never fails that the day after you've created a timetable, someone comes up with an exception. This changed, now I need to, what you gave me in the timetable doesn't work, so you have to make adjustments. We have an interactive change process that allows minimal changes to the overall solution, but finding a solution that best meets the change needs in the problem. We also have the ability later on to make a more manual change. I need to make a change to this room in the problem. It doesn't have a large effect. You can go in and just make that change to the problem solution, and it gets propagated through everything that's needed, particularly the student scheduling, which often is taking place at the same time. You're having these minor changes. So if you have to make a room change, it's automatically reflected in the student's schedule, and they receive email notification of those changes, and they can go online, and the schedule reflects the change in rooms. Or if there were a change in time, though that's fairly rare. But everything's integrated so that it works together in finding a solution and communicating it to those who need to use that. We also, at the end of the process, then can roll forward the data into the next term or a next like term more often. You can go from one term to any other, but more often people will take fall data and roll it to the next fall term, or spring data and roll it to the next term, because there's more similarity in course offerings between one term and another. This brings up the student scheduling problem, which is the next major component of our software. And the question is, why is scheduling needed once you created this wonderful timetable? Well, if all courses were single section courses, you wouldn't need to do student scheduling. The schedule for the student is determined. It's what courses you take and what time they're offered. But the moment you have multiple offerings of a class, you have a problem with what is the order of filling of those classes. And that becomes a major problem. If we use the same example as we had before, if I'm a student and I want to take both, well, in this case, if I'm trying to take math and chemistry, but two sections fill early, section B of the lab in chemistry and B in the lecture of math, that leaves me only two choices, or one choice in time for both. So they're going to end up as a conflict. What you want to do is to be able to distribute the students across those classes in a way that allows most of them to be able to enroll in the classes that they choose. What we've done, we provide a number of ways of doing scheduling, all of them based off of a fairly simple interface, which allows students to fill in their course requirements or requests, allowing them to put in priorities for the courses, because they may have conflicts that result just due to the timetable. Often we have students who don't look at the published schedule and say, I want these two classes, they're both single section classes that meet at the same time. So we want to know their priorities. We want to know alternatives. If I can't get into that class, is there an alternate class that I'd like to be in? And also allow students to put in time availability. A lot of students have jobs that they may need to work around. So if they need to be free at a particular time, they can put that in the schedule or their schedule requests, so that we can do the best job possible of trying to give them classes that meet at the time that accommodates their work schedules. When that's done, the system in the automated mode will suggest a schedule that best meets all of those student needs. And the student can then go in and make modifications as they feel they might need to. Essentially, there's two options in the scheduling process. One is a batch process, which is the best for optimization. It takes into account all of the needs of all of the students and tries to come up with a best match schedule for everyone. And that's usually done if you have pre-registrations for your classes. If you have a source of data where students either pre-register or curricula data is fed into your system, that you can create a pre-registration for students because you know what courses they need to. You can use that to give them an initial schedule, which they can then go into and make modifications as necessary. The second option is what we call real-time scheduling. You can produce a timetable and not run an optimization through it in a batch process, but let students enroll one at a time. Often it's more common that people feel they want to go through the system in this method It's not as efficient, but we've done some things with algorithms to make it nearly as efficient as a batch process. We do that by holding spaces for students based on historical and expected demand information based on what we know about the student body and what we know about the timetable that we have created. The system also allows for reservations to courses. If I have a math class that's intended only for engineers, I can restrict it to only being engineering students, for example. Automated waitlisting, which is essentially a process of any student demand that isn't fulfilled, the system remembers it, and if there's an opening in the class, they will be enrolled to that class and sent notification that they are now able to get into that class. We also allow for instructor or departmental consents for students to get in courses. So there may be an honors course, for example, that requires consent of an instructor or program. We have a number of advisor roles that let advisors see what's happening in the system or to register for classes for students if that need be the case. So there are a lot of functionality that meets most of the scheduling needs of students. Other major features of the system, as I mentioned, we have examination timetabling. We can do examinations on a number of different levels. It can be anything from a class exam. I have multiple recitations of a topic. If each wants its own exam, they can have those. I can have a course-wide exam. Or I can have an exam that spans multiple courses. In all of these cases, the time in a room is located for the student or the exam in a way that tries to minimize the number of conflicts that occur. We can also handle multiple examination types in the semester. You can have midterm exams, final exams. You can even have multiple occurrences of final exams during a session if that be necessary. In all of these cases, our primary concern is to minimize the number of direct student conflicts, also to minimize any back-to-back conflicts that may be occurring, and in final examination problems, we look at the number of exams that occur in a day, trying to minimize more than 2 exams on a day, for example. The other major feature in the system is event management. What we've done here is we've very carefully coordinated the management of the remaining time in classrooms that haven't been scheduled for classes so that they're available for various student events, meetings, symposia, all of the other things that want to make use of your classrooms. Now, I say classrooms, that's how we started. We have expanded to where you can manage multiple types of rooms. You can manage conference rooms. You can manage other meeting rooms on your campus with the system. But its real intent is to manage academic spaces because you need a coordination between those. If I have to move a class during the middle of the semester, I need to know what other events were put in rooms. So is a room available for me to move a class? I may have some event, actually, the president has some type of colloquia that needs a large lecture hall on a particular period. I may actually want to schedule my classes around those. So if I have an event in a room, I can schedule classes around an event if necessary. We usually don't recommend that, but the capability exists that there's a communication between anything that happens in the event system and anything that happens in the class scheduling component of the system. We recently made some additions to the event management system where it is fully distributed in that you can have any department managing their own spaces rather than going through a central administrator of the spaces. So departments can opt to schedule various conference rooms, laboratories, any space they wish to within the department outside of any central management. So that space is under their own direction, which is a major advantage to most of our users. They like to have control. The system also, in order to make it more friendly, we have allowed various data exchanges, XML interfaces for importing data into the system. We've built some custom interfaces. We have some hooks. More of that can be done. There are also a number of other nice features of the system where we can define things such as travel times or distances between locations. Sometimes conflicts are not because something's directly on top of each other in terms of time, but it takes a half an hour to get from one east campus to west campus if you have an arrangement like that, so you have to take into account travel times between courses. We have the ability to define travel times between locations and take that into account in the scheduling of classes, as well as for keeping track of, even if there isn't a conflict, alerting students that they face a very short travel time in order to get between classes that don't conflict. So, for some conclusions, we think UniTime provides a state-of-the-art package of tools for scheduling. Includes course timetabling, examination timetabling, student scheduling, and event management. The system is very general, can be applied to many institutions of higher education. We have applied it to a number of universities internationally with actually, on the face of them, quite different problems. But because of the structure of our software and the model we used, it adapts well to a large number of problems. We won't say all problems. There have been a couple of people we said, "You're kidding. You don't really want to do that using our software, do you?" It is easy to customize in terms of new constraints and other aspects of the problem. It's capable of adapting to very large institutions. Purdue University, where we started, is an institution of 40,000 students, which is on the large side for most institutions. We have no problem keeping up with solving a problem of that size, either distributed or as a single problem. We've run the university both ways. As I said, we have users around the world. We've been gaining a lot more interest internationally. It's a problem in certain areas where they don't have the resources we have. That it has become very important for them as they get larger populations of college-age students to be able to accommodate their needs in an efficient manner, not just building more rooms. So timetabling has become important for them. As I said up front, we recently joined the Apereo incubation process, and we're hoping to work with some of you on suggestions or maybe interfacing with you, or if you're end users, hope you'll give us some consideration. For more details, I've put our website up here, www.unitime.org. We're also going to be doing some demonstrations at the tech demo reception tomorrow evening at 5:30. So any of you who would like to stop by and shake the tires, we'd be happy to show some things off to you that we couldn't show here because of the time limitations. We also have an online demo at our website, demo.unitime.org, that we would invite you to try out if you have an interest. We set up a little institution, Wobegon University, that you can try out and see how the system works in detail. With that, I'd like to open this up to any questions you may have. Yes?
Sure. I have a couple. How do you manage, or do you manage resource scheduling? So not simply just rooms, but the equipment within rooms, or freestanding equipment that wanders.
We don't specifically do that. We haven't had a requirement. You can. It would be possible to make some changes and treat resources similar to rooms, because rooms are, the way the problem is structured, are modeled as a constraint problem. it's another resource. We face this with how do you handle instructor availability, or if you want to do instructor scheduling. They're a resource. You can add them as a resource to the problem. We haven't had the demand yet, but Tomas here, who's our lead programmer, can explain, but it is quite possible to handle that in the problem formulation. Do you have a follow-up, or?
I have lots, some of which we can take offline.
Okay.
Okay.
Dan Barton from UniTime.
Yeah.
What would you say would be a product a commercial product that's very similar in terms of feature set, or is this unique in terms of its scope and scale?
The closest commercial product in the U.S. or North America is InfoSilum. Yeah, sorry, I was drawing an InfoSilum. It's out of Canada. InfoSilum. InfoSilem. The major difference, they're the only other provider that does a true timetabling, time assignment as well as room assignment. Most products will do a room optimization. You have to have your timetable already. So they would be the closest. They don't do a distributed approach to timetabling as well. They're not open source. You can't find out what's under their hood. I do know the principals, and they're good people, but it's, at the time we were looking, they didn't have anything that would deal with a problem like ours. Question? We'll go back and forth.
Integration with other systems like Banner.
Yeah. We are actually there are a couple of things. One, we've been working with IMS Global. They're coming up. In fact, they have a candidate public release of an extension to the LIS standard that incorporates integration between student information systems and scheduling systems. We worked extensively on that. So basically, we wrote a good deal. Stephanie here wrote a good deal on the specification, and we're working on setting up test instances for that. So when that is available, fully available, that's one avenue. Right now, we're also working with Lucy and Banner, because Purdue is a Banner institution, to do a direct integration with Banner. It has some additional functionality.
We do currently have a course bank that we have to write for Purdue, so that we could function in Purdue. So.
Yeah, what we're doing is we're expanding on that for the student scheduling functionality, that you can automatically run any, all the requests would go into Banner. They would do some checking in terms of eligibility to register for a course. Have you met prerequisites and co-requisites? We don't get into that. That's student information system territory. But they would then tell us whether students was eligible. We would communicate that back to the students in real time as they're going through the process. And we had another one.
Authentication, CAS enabled, local.
Currently we use Spring Security for authentication and authorization. It's usually set up with LDAP. I've tried to play with CAS as well, but we don't have an institution using it with SAS yet.
Any questions from the left side? We'll go back to the right side of the room. Anything else, or we can go offline.
Yeah, some of those I'd love to talk with all of you about. I work on a favorite project.
Yep.
Primarily a UI person, but we have a new project that's come to us. There's, for example, for faculty schedule availability, or therapist schedule availability, or doctors or so, which applies essentially availability overlays on top of a very busy person's actual calendar, which allows people to sign up for those things, which I think is interesting relative to some of the things that you mentioned, and that's now called or sometimes the University of Washington scheduling system.
Yeah, I've seen that.
Yeah, so that's interesting to me. But this is fascinating because I actually had a need for this product for a project on my own campus, which would be interesting because then I would love to see it integrated through a CalDAV so that other users can look, should they choose, at the actual schedules for rooms right on their devices.
Yeah.
Do you guys provide?
We actually have it. You can provide personal schedules, your own personal schedule on a mobile device. Well, it's through iCal standard.
Yeah, it's essentially in the event management, any query you can create, it can export that query to iCal. So you can have a room schedule, a personal schedule, or a list of events that needs your approval or things like that as an iCalendar.
But there are things we don't do. For example, you publish a calendar. So, for example, if the university has a calendar, a public calendar, I faced this problem with Quest years ago that we were trying to suggest ways of taking all the various scheduling entities in the institution and automatically feeding into a calendar like you were displaying this morning. And the IT folks at the university really didn't follow on what that is. There really is a need to take things from a system like UniTime, and if it's something that wants to be publicly displayed, automatically export it to a system like Beadwork that people have that rather than dual entering it or. So I can see some good areas for integration.
Yes, sir. Do your calendars, do the schedules here get exposed publicly as they currently say? Can people go and say, oh, what's the room schedule?
Yes.
Yes. Well, within the way we have it set up, and there are differences in the security levels. We have it set up that any student or staff member at the university can see what's happening in any room. Although there is the ability to hide individual rooms, and that's set up the room level basis. But by default, yes, you can see what's happening in any room. So you can, if you want to schedule an event, you can see what's in the room, or basically it actually just automatically pulls those in when you query on, I need a room at this time, what's available.
And essentially, any student can request an event at any time, and then there is an approval process where an appropriate event manager of that room can say yes or no.
It's exciting for two reasons. One, because of the calendar, but also because I actually have a need for this right now.
Well, we'll talk to you. Is there anything else? If not, thank you very much for your attention and a warm welcome to the Apereo community.